7.5 is on the law of sines. Now, I'm used to teaching the law of sines in my AMA class. That's the one that comes after Math 3. But Math 3 Honors and AM and AMA all teaches the law of sines. And we've added it to what you're doing in Honors Math 2. That way you can skip a class that we had in our old curriculum. What the law of sines is useful for, since you've learned sine, cosine, and tangent, well, that only works for right triangles. SOHCAHTOA only works for right triangles, but there are two laws that can be used on triangles that are not right angles, that do not have to have a right triangle with it. So the first one that we're learning in 7.5 is called the law of sines, and it has these three ratios equal to each other. You will only use two at a time, meaning, like if I cover up this middle one, you will use these ones, or you're going to use these two, or you're going to use these two. You will not use all three at the same time. You are going to use two at a time. Okay? They can be used when given angle, angle, side, or angle, side, angle, or side, side, angle, which was one of those ones that we couldn't use earlier on. The hardest part for most students to understand is this thing right here, this line. Each ratio must be made from the angle and the side that is opposite the angle. What that means is this. When I look at sine of big C and I have a little c, big C is the angle, little c is the angle or the side that is across from angle C. Let me show you a little picture. If this is A and this is big B and this is little c, or big C, they're all A, big B, big C, then little a will be what's across from angle A. This is little a. It has to be that way. Big B, what's across from big B is little b. What's across from big C is little c. That's how you set up these problems. That's how you know what goes with what, based off of the angle and the side that is across from that angle. This and this go hand in hand with each other, just so you know. I only put this next sentence because of my AMA. When given side, side, angle, it is possible to have more than one answer, but as far as I know, we are not covering that here. Just in case you learn something later on and say, Mr. Brumman, you never taught us this back when we were freshmen and sophomores in Honors Math 2. I'll say, yes, I did. I put it in there. There is a possibility to have more than one answer, but we are not going to cover any cases where there will be. There's something called an ambiguous case, but we are not going to cover it here. Okay, it'll show up later on in AM or an AM if you go that route. Okay, we're going to set up one proportion at a time with three things that we know and one thing that we don't know, meaning you're going to know this one, this one, this one, and try to find that, or you know these three and you're trying to find that. You're going to know three values and you're going to use it to find the fourth value. Sometimes you're going to have to subtract from 180 degrees to find the third angle first. So let's go ahead and do an example. I have two examples that we're going to do, and then we'll have one more thing to write in our notes, okay? So you can decide, oh my goodness, cancel. Let's do number 2. If you want to do this in your packet, you are welcome to do so. Number 2 says, for problems 1 through 9, solve for all missing sides and angles of triangle ABC. Do we have a right angle here? So you cannot use SOHCAHTOA. You can't use sine, cosine, or tangent. You can only use SOHCAHTOA when there's a right angle. There is no right angle here. Do not assume that there's a right angle if it doesn't have a right triangle in there. So what are we going to use? We're going to use the law of sines. How do we use the law of sines? We have an angle. We have angle C, and what's across from it. So the very first thing I'm going to do is I'm going to use angle C. I'm going to use the sine of big C. And how many degrees is big C? It's 104 degrees. The sine of 104 degrees. And what is across from it? What's the side across from the angle that's 104 degrees? Good. That is something we know. This is a value we know. We know what's across from it. Equals. We know one more thing. We got to use something we know and then to use it to figure out what we don't know. I see that we have a value of 16 here. What letter is that? Little b. Don't just say b, say little b, so you know that we're talking about a side length. A side length. Little b will end up going on bottom here. Does that mean that we know what big B is, that angle? No, but it can be our unknown. We have three things that we know. 1, 2, 3. One value that we don't know. So we are setting up our first proportion using this ratio and this ratio, but we don't know it. So here's what I do, and this is what I'm going to recommend that you do. If I'm trying to find angle B, the first thing I do is I multiply by 16. I'm just going to write my second step right below here. Most of you will just do your work along the problem. I would times by 16 and times by 16. It goes to the numerator. That 16 is in the numerator, so I keep it like that. I still don't have angle B by itself. There's a sign in front of it. To get the angle B by itself, what I usually do is I'm going to do, well, let me do step 3 down below it just so that I don't confuse you. Sine of big B equals 16 sine of 104 degrees divided by 25. To get this B by itself, I'm going to do the opposite of taking the sine of it. I'm going to take the inverse sine so that those cancel each other out. I'm going to take the inverse sine of this whole thing. The inverse sine and the sine will cancel each other out. What you'll be left with is what angle B is equal to. And so you'll have to plug this whole thing into your calculator to figure out what angle B is. I'm going to turn this little light on so you can hopefully see my calculator screen. Inverse sine. If you want to use the fraction button, feel free to do so. 16 sine of 104 degrees. Make sure you put your end of parenthesis in there. Some calculators will give you an error if you don't do that. 25. And then I usually put an end of parenthesis at the end as well, just so I don't get an error. If you get an error, then a lot of times it's due to the parentheses in your calculator. But I want this to match up with what I have there. And notice that'll give me over half the points for partial credit if you've made a mistake. Press equals, and I see 38 points. And what am I going to the nearest? Does it say? Well, if it doesn't say, please use the nearest tenth of a degree. That'll make our lives easier. 38 point, nearest tenth, 38 point what? 4. 38.4 degrees is our angle B. Turn that light back off. 38.4. I can even put it in the picture now. Will angle A be pretty easy to figure out now? This is where you could use the law of sines again if you want to find out what angle A is, but I would just subtract from 180 at this point. So to find angle A plus 38.4 plus 104 should equal 180 degrees. I'm going to take 180 and I'm going to subtract 104 and I'm going to subtract 38.4 to see what is left over. Any questions so far? Then the last thing you do, solve for all missing sides and angles. We have all the missing angles. We do not have the other missing side. We still need little a. How are we going to do it? Can we use the Pythagorean theorem? No. You cannot use the Pythagorean theorem because it's not a right triangle. Pythagorean theorem, SOHCAHTOA, only works for right triangles. These are not right triangles. So therefore, we still have to use the law of sines. Now that we know what big A is, we can actually use the sine of big A over, we don't know what little a is equal to, I would probably go right back to that beginning of the sine of big C, since that was one of our givens, over little c. What did I press? If I press X, well, let's see what happens there. Okay. So this is how I would set it up to figure out what little a is. The sine of big A over little a equals the sine of big C over little c, because I knew those values and I'm not approximating like what angle B is. There's no approximation here. I'm going to be more accurate that way. Now, how do I find out what A is? You can never solve for a variable in the denominator. I'm going to recommend that you use the reciprocal of this side and the reciprocal of this side. Most of you, that should be just fine. There are other ways to do it. And then what I'll do is times by sine of 37.6 and times by sine of 37.6. Sine of 37.6. Sine of 37.6. That and that will cancel out. So then I can figure out what A is. A is going to be 25 sine of 37.6 divided by sine of 104. So let's see what little a is going to be about equal to. 25 sine 37.6 end of parenthesis divided by sine of 104 end of parenthesis. And I'm getting that little a is about equal to 15.7. 15.7 to the nearest tenth. Make sense? That takes us to number 8. Number 8 is very similar to that, except they don't give us a picture this time. Well, just like I told you before, the angle being the big letter is always going to be across from the little letter that is across from. So we can go right into it. I feel like I need to move this out of the way. So how do I press enter? I need more room. I have to open this up. That's the better. So let's set this up. And I'm going to set it up. I'm going to show you, now that you've seen the first example, I'm going to show you how I actually set these up myself. The first thing that I do is I go like this. I write sine 26 degree, big A. Do I know what little a is? It's not given to me, so I'll put little a. Do I have angle B? I'm given little b. Is that angle B? Okay, so you may have to subtract from 180 degrees to find the third angle first. Can I find angle B real quick? Let's do that. What is 180 minus 26 minus 35? I got 119 degrees. And then what I do, just because of, to save a little bit of room, is I write the sign of big C over little c as well. Even though I have all three written, I'm only going to use two at a time. Because these are proportions, you kind of get used to multiplying, and then dividing by the thing you don't know. So for me, I can do a lot of stuff in my head, and so I will use this side to find A, and what I write is like this. I go, little a will equal these two multiplied, 13 sine of 26 degrees divided by the sine of 119. Now, if you can't do that in your head, don't freak out. Just do the math, work it out, do it in 2 steps if you need to. But that's how I'm going to find little a. I'm not going to plug it in yet. How am I going to find little c? I'm going to do my math over here. I'm going to cover up the a values. I'm going to use the known and the unknown. I have one unknown over here. I'm going to use these values over here. Cross multiply. 13 sine of 35 degrees divided by sine of 119. So I have one of my answers already, the 119, and I'm going to use my calculator to find these other two values. Little a, 13 sine of 26, end of parenthesis, divided by sine of 119. Have you already done it? Has anybody already done it yet? No. Okay. Then this is what I'm getting. You can check my answer when you do it for homework, 6.5-ish. I'm going to do the same thing. This is the least amount of work that I would expect from you. Just so you can know. There you go. The last thing that I want you to write down in your notes are these 3 formulas. To find the area of any triangle using SAS, you can use any of these three formulas. 1/2 little a times little b times sine of big C, which is the same thing as 1/2 little b times little c times sine of big A. Or you could even use 1/2 little a times little c times sine of big B. The angle has to be the included angle between the two sides. That's why big C and then it goes little a, little b. That's why it goes big A, little b, little c. Big B, little a, little c. What's the advantage of these three formulas? Now you don't have to have a perpendicular height. Now you don't have to have a base times height because you can use the outside of triangles that are not right triangles. This works for any triangle. So let's see how it works. Number 10, this is our last example. Find the area of triangle ABC with the given side lengths and the included angle. You could draw a picture if you wanted to. You don't need to. I can use my area formula. That works for any triangle. 1/2 little a, 1/2 little a times little c times the sine of big B. Well, I have little a. 1/2, 9. I have little c, 11 times the sine of big B, 124 degrees. And it's just a matter of plugging it into the formula. As long as the included angle, you are okay. Is big B between those two things? Yes, it is. So I'll take my calculator and I'm going to type this. 0.5 times 9 times 11 times the sine of 124 degrees. Does it say? It doesn't say. So let's go to the nearest tenth. 41.0. Any questions?